When you sign a crypto transaction, do you know what it actually is you're approving? Because for most ledgers, the answer is going to be no. The data actually being submitted to Ledger is some kind of encoded binary or hex string that requires decoding before you can even begin to understand what it's going to happen. People these days seem to be completely fine with blind signing transactions, which basically means you're signing a transaction before you even know what it may do, which is really strange, especially for an industry that supposedly values trustlessness. This is why Radix and the Transaction Manifest make using crypto so much safer. So, transaction manifests are human readable lists of instructions that are followed by the Radix engine to transfer resources or otherwise change state. What that means is anytime you're using the Radix ledger, whether that's dApps on your desktop, sending cryptos to a friend on your phone, or even an arbitrage bot running on its own, everything boils down to a transaction manifest that is actually submitted to Ledger that is accomplishing those state changes. To understand why transaction manifests are so useful, let's start by looking at what a transaction looks like when submitted on other ledgers. Here's a random transaction that I grabbed off of Etherscan. You can see this person's interacting with Pendle, and to see what it actually looks like being submitted to Ledger, you can come down here and check out this input data. Now, I have no idea what any of this means. If I were trying to understand what this says, even with my limited development experience, I have no idea where to begin. Here's another random Uniswap transaction that I grabbed off of Etherscan. Looks like someone's swapping ETH for a Trump meme coin. Again, you have no idea what is being submitted on your behalf to the ledger when using something like Ethereum. All right, here's a transaction from Multiverse. This is also a swap transaction from one token to another. And this is what the input data looks like on Multiverse X. So yeah, not even sure what all this means. Apparently, asking Claude, they format it by an action and then a token identifier and then an amount and then a function name and then arguments, but it's all in, nothing you can easily read. This seems like you're still blind signing if this is what is presenting to you to sign. So here's a transaction on the Sui blockchain where Deep and Sui are being added on Bluefin as liquidity. So you can come down here and you can see the inputs of the transaction, and then you can even look at it raw. But my understanding is this is just the decoded JSON of the raw binary code, which I can't even tell you really what's happening in this raw, JSON right here. Maybe I'm an idiot, not, totally a possibility. Now let's take a look at a random swap transaction on RadXplorer. First impression, hopefully you can see at least it is written in actual English and not some just binary or hex string. It does have addresses and component addresses and resource addresses and that sort of thing. But we're about to go over step by step of how I would approach reading something like this and being able to understand it before you submit something to Ledger. The first thing you should do if you want to start reading and writing your own RTMs would be to get an IDE or somewhere to actually write them. I like VS Code and I really like Cursor, which I'm trying out now. It has a really cool AI integration. If you don't want an IDE, you can always do something as simple as a notepad or any kind of text editor. Let's start with an easy RTM from the docs. This manifest is a simple token transfer. So what we're going to do is we're going to take each instruction one at a time and read it from top to bottom and try and figure out what's going on. In the first instruction here, the thing that sticks out to me is I see my account address and lock fee and 10. So what this instruction is doing is taking 10 XRD from my account and locking it to pay the fee for the transaction, just to make sure that this account has enough XRD in it to pay for whatever may follow in this transaction. The second instruction, again, I see my account address, so I know it's involved, is withdraw. So what's happening is this is the XRD address. It is withdrawing 10 XRD from my account in this instruction. One useful thing to know when working with transaction manifests is when tokens move, they have to exist somewhere. So when you take something out of your account, it goes to this imaginary location called the worktop. So the next instruction is take from worktop. So the tokens we just put on the worktop, we're going to take them and put them in a bucket. Whenever you move tokens from place to place on Radix, they have to be in a bucket. So this instruction, take from worktop, we're taking the XRD address, the same amount that we put on the worktop, and we're going to name that bucket XRD just so we know that what's inside of it. And for the final instruction, we are going to try, deposit, or abort. I mean, we're going to try to put it in someone's account, and if it fails, then we're just going to fail the entire transaction. So again, this is my account address. So we are taking a bucket of XRD out of my account, putting it on the worktop, and putting it right back in the account, which doesn't make a lot of sense, but you could put your friend's address here, and you would have a simple transfer. You could repeat these steps multiple times, and you could start building yourself an airdrop. Let's take a look at a little bit more complex transaction. This is a swap here from XRD to early. And just looking through the balance changes here, it looks like it's being aggregated through two different pools, and a component is taking a small fee. This is the user's account, so you can see that they're gaining this much early and spending this much XRD here. So let's take a look at the manifest. So we start off again by locking a fee from the account to pay for the transaction. Next, we have withdraw 4,000 XRD again from my account. Remember that XRD went to the worktop, and so what this instruction is doing is taking 250 of that 4,000 and putting it in a bucket called bucket 1. The next instruction takes the bucket 1 that we just collected and uses the swap method on this component. The next instruction takes the rest, so we're taking all of the rest of the XRD and putting it in bucket 2 from the worktop. Then we're calling yet another component, and we're swapping with bucket 2. These two instructions here are about transaction guarantees. So to show you what these transaction guarantees look like, I can start a swap. Trying to swap 1000 XRD for early, but let's say that I want to make sure I get exactly what is shown on the screen, or else the transaction will fail. I can set my guarantee to 100%, or any percent under that if I like. And make sure it does, and to make sure that if I don't get exactly what is shown, that I spend nothing other than a small transaction fee. This is so much more powerful than setting something like slippage on Uniswap, because that doesn't actually protect you. Just because you set slippage on Uniswap doesn't mean that you're going to get exactly what is shown on your wallet. It could have a huge sell of a token that you're trying to buy get executed before your transaction. You could be sandwiched between two bots and get a much lower price. Setting slippage is not the optimal way to make sure you're getting what you're actually wanted to get to begin with. This will actually fail the transaction, and you cannot process the transaction unless that amount of tokens are returned to your wallet. Okay, so back to RadXplorer here. You can see that we're asserting that the worktop contains a specific number of tokens, and that is what is used by the wallet to make sure that those tokens are actually there before you continue with the transaction. And then the final instruction is deposit batch. Again, with my account address, we are depositing everything else that's left on the worktop into my account. So that's kind of how I would go about reading these transaction manifests. And these manifests can even get kind of long depending on what all you're doing. But that's actually a feature, not a bug. You can just start adding on instructions and composing together different transactions with different components on Ledger very easily, just like this, without even writing any actual code. It's really helpful to be able to copy RTMs if you're building some of your own. It's a lot easier to just edit some than to just make them from scratch. So if you notice, there's a button at the top right of this transaction screen here that you can click, and it will show you the exact manifest that is about to run. So this is all also how you would verify what you're trying to do in a DApp is actually happening behind the scenes and is actually getting submitted to Ledger in the way you want. So you can copy them directly from the transaction without even submitting the transaction, or you can just grab a transaction on the Explorer, and you can come to the Manifest tab, and you can copy anything like this and start editing, changing your own address, your own components, that sort of thing. Now let's try to build a custom RTM as if my account were going to make an arbitrage transaction between Caviar 9's USDC pool and OCSwap's USDC pool. For this, I'm going to use a really powerful platform I've started using called Instruct. Let me show you how it works. First thing we need to build this RTM, though, is going to be my account address, which we have here. And we need to find the USDC XRD pools for those two dexes. So I'm going to go to RadXplorer. I'm going to look up the USDC address. I'm going to find the holders. And I believe this one is the, yep, that's the Caviar 9 pool. And I think this one is the OCSwap pool. All right. So now we have the appropriate addresses. Let's think through the steps here that I would need to do. I would need to withdraw some XRD from my account. I would need to put it in a bucket, and I would need to pass that bucket to the first DEX and swap it for some USDC. I would then need to take all of that USDC in another bucket and then pass it to the second DEX where I'm doing the arbitrage and swap it back to XRD. And then I would need to put that XRD back into my account. Let's see if we can do that. So the first thing we're going to do is call method. And for the component address, we were going to put in my account. And what we're doing is withdrawing. What we're withdrawing is XRD. I'm just say we don't have that address handy. We're going to go here and copy it from the Explorer. And we're going to use the amount of 100, let's just say. Let's add another instruction. Like I said, we're going to need to take that from the worktop, and we can just go ahead and take all of it. That same XRD address I'll paste here, and we're going to call this bucket XRD. Okay, let's add another instruction here. And now what we want to do is call, we want to do a swap on the Caviar 9 DEX. So we're going to do call method. And the component address in this case will be the Caviar 9 pool. So we're going to paste that address in here. And one really cool thing about Instruct is if you forget what kind of method names there are for a given component, like OCSwap and Caviar use slightly different method names, it auto-populates them for you. So this is everything, every method that I can call on the Caviar 9 pool here, which is freaking awesome. So we're just going to do swap. And since I've already named my XRD bucket XRD, I can just select it here. So now we have withdrawn XRD from my account. We've put it in a bucket, and we've now swapped that XRD for USDC at Caviar 9. So now we want to take all of the USDC that we had just swapped for, and let's see, I need to look up the USDC address again real quick so I can get that here. And we're going to call this bucket USDC. Now we're going to take that bucket of USDC and we're going to swap it through the OC swap component. So we'll get that here. We're going to call method on the OC swap component address. And again, if we don't know what we're going to get, we can just come through here, hit swap. And we need to specify that we're using this USDC bucket that we just created here. So the last thing that we want to do here is deposit into our account. So I'm going to go back here, get my account address, and I'm going to call the deposit batch method on my account, and everything in the worktop that's left over is going to go straight into my account. So one more time, let's go over exactly what's happening here. We have withdrawing 100 XRD from my component address, my wallet. We're going to take all of that XRD and put it in a bucket called XRD. We're going to use that bucket and swap it at the Caviar 9 XRD USDC pool. We're going to take all of the USDC that is returned from that, put it in a bucket called USDC. Then we're going to take that USDC bucket and we're going to swap it at OC Swap's XRD XUSDC pool. And then anything that we get back is going to be deposited back in our account. So this is how an arbitrage transaction would work if you were able to detect that, hey, there was for sure an imbalance between Aussie Swap and Caviar 9. You could run this transaction and even specify that a certain amount has to come back into the account, and just to make sure that the transaction is profitable. And if it wasn't profitable, the transaction just simply would fail. So let's see if we can even get this thing to run. Look at that. So in this example, I'm taking 100 XRD and I'm receiving just less than 100 XRD after those two swaps, which means which just means that it's not a profitable arbitrage opportunity at this second. Now we can add a transaction guarantee right before we deposit things back into our account. So if we come here and we put assert worktop contains, I'm going to paste in the XRD address here, and we're going to say 100 and 0.5 to cover transaction fees. So this would make sure that there is an arbitrage opportunity, or it just simply wouldn't run. So let's see what happens when we try to execute. Nope, won't run because there's not an arbitrage opportunity. However, if we wanted to change this up and just show you that it could still run, we can make this a 99.5 here. And it'll go through. So that's how you could kind of guarantee that if you're making like an arbitrage transaction or running an arbitrage bot, you could make sure that it is absolutely a profitable transaction before you even attempt to complete it. One more really cool feature of Instruct is that you can just import manifests and easily edit them and use them for yourself if you need. So if we come to the Explorer and just grab whatever first transaction is here, look at that, it's a long manifest. We can take it, copy it, come to import, paste it in, and boom, we have this whole manifest right here. If we needed to come in and start, changing address to use for me, I could come in here and just start pasting in all of the addresses where I need them and so on, and kind of customize the transaction and do what I needed it to do. So I hope you can see how powerful Radix Transaction Manifests are and why I think they're probably one of the coolest parts of the Radix tech stack, because they give you safety and clarity and actually show you what is about to happen in a transaction. I really don't know any other ledger out there that offers anything close to this. It seems like every other ledger, you're blind signing no matter what. Um, they don't come with transaction guarantees. And in order to string together multiple smart contract calls or use multiple smart contracts in a single transaction, you either have to write a completely new smart contract or you have to rely on third-party software, and open yourself up to more surface area for exploits. There really just is no other comparison as far as submitting instructions on Ledger, in my opinion. Thanks so much for watching, guys. And drop me a comment below if you decide to write some of your own transactions. Let me know what kind of transactions you're working on.